What we are trying to do here is propose something new, a methodological approach which focuses on observation only. Why? Because the quality of the observed data is usually relatively bad. And if you have a relatively low quality of the observed data, of the observations, then any modeling which you do upon that is flawed. So if you want to have a relatively holistic, requisitely holistic models, you need to have holistic perspective data upon which you build the models. And this is why we developed a methodology called interactions observation. Okay. I'll try to click here. Perfect. Nope. Of course, it went the other way around. So the methodology is called cybersystemic interaction observations, and it is meant to provide a requisite holistic perspective, especially in a way where multiple people can put their observations on multiple observation points. And let's have a look what can or should be observed. We are talking about observing interactions, and interactions are particularly important because two systems have an interaction. Okay, now we are observing two things: the structures and other interactions which are related to the observed interaction. And in the structures, we took a part of VSM and said, come on, VSM is not correct, or maybe can be improved. Because if we focus our observation on an interaction, we can see that the system never communicates with the environment. The system always communicates with another system, which can be in the environment, but it is always a system. So basically you have a system-to-system communication, interaction, never actually a generic system to environment interaction. And this is why we modified the original VSM model and said, okay, we don't have system and the environment, but we have system 1 and system 2, as you can see here. And the interaction is either on the managerial part or in the operational parts. Okay? The equations are relatively simple because we state that the environment, the system 1, the system 2, and the existing relation between system 1 and system 2 affect the interaction. Okay? And the second one is for the loop. Basically, the interaction modifies the environment, system 1, system 2, and the relation between system 1 and 2. So it is a very, very generic set of equations, because what we wanted to achieve is to generate a universal observation methodology for observing interactions, which can be in the society, in the organizational space. It can be in biology, chemistry, physics, you name it. Okay? Everywhere where you can find interactions between two systems. So, what is environment? It's a place where general structures for enabling interactions reside. Some, in most, basically every interactions need an environment. Okay? Then we have this system 1 and system 2, which we kind of modified it a little bit. So we said we are not as granular as you would like us to be, maybe, but we have management subsystem 1 and 2 and operational subsystems 1 and 2. And of course, the structures also reside in relations between systems 1 and 2, which is important because really, if you think of it, interactions are building relations, and relations are the path for the new interactions to occur. Just think about that. What is the relation between relations and interactions? Okay, so we're observing structures, and we try to identify all necessary structures to observe. Okay, but there is something missing, because interactions are related not only to the structures, but also to other interactions. Okay, now which interactions are these? Some interactions are repetitive. So basically you do something all over the time, repetitive interactions. And these are really, if you're looking at one interaction, usually you have several pre-interactions, and after this interaction is going to be executed, there will be other interactions. For instance, we are right now in the conference of Metaforum, and this is not the first conference of Metaforum, and we can only hope that this is not the last one. So repetitive interactions are really important to understand what is going on with the interaction. Then we have sub-interactions, which are executed as a part of the observed interaction, the environment interactions, the interactions which happen in the environment, okay, and many loosely related interactions which don't have a completely strong relation with the observed interactions, but can affect it, okay? And these interactions, all of those can be either supporting or constraining. So if you have an interaction which is supportive, for instance, I don't know, financing the Metaforum, obtaining some finance for a Metaforum, this is a very supportive one. Constraining, I don't know. You can think of constraining interactions. And to visualize that, we relied to the system dynamics graph, which is circular. So basically, you have the system 1, system 2. It is an action, and then we have a reaction, okay? And subsystems of system 1 and system 2 and the environment. And they are producing these interactions which are going on. So these are the elements which should be observed when you want to understand what the interaction is all about. Okay? Is this everything? No, because you can observe the same interaction in multiple ways. Okay, first of all, you need to decide who is the observer, and you can have multiple observers of the same interaction with different elaborations of what the observation results are. But each interaction happens in time, so it takes a while to happen, and usually it takes, if you look at the time of the interaction, it starts with the planning of the interaction, preparation, execution, and post-interaction activities. And basically it ends when the effects of the interaction to the system, to the environment fades. So we have this time span of interaction, and that means that we can observe each interaction on different time perspectives at the start, at the end, wherever you like. Okay. And the next one is the zoom level. So we can decide whether we would like to observe the interactions from close or from far away. So we said, okay, let's normalize that. And we say, okay, let's have a zoom from 0 to 1, which means 0 is, let's look at the interactions from far away. And 1 means let's look at the close-up of the interaction. Okay. And then we have time, which can be also normalized. And we say time goes from -1 to 1. -1 means, okay, it's we started to think about the interaction. Okay. 0 usually means, okay, that's the time of the execution. And 1 means, okay, now all the implications of the interactions have faded away. Okay, so now if we want to create a report on the observation, it should be semi-structured, which means some structure, something should be defined, explaining what are we observing, how, in which point, which parts are we observing, and then we have the observation part, where we report on the observation, which is not structured. So we have this semi-structured structure. Why this is important? Because this can be understood very well, not by humans, but by AI. Okay? Now, this is a short diagram of the observation points. If you can see the first observation point, the second, and how many observation points would you like to have? As many as you like. So you can decide which observation points are important for which observation. Okay? Is this too unclear, too chaotic? Let's have a look. By the way, if you would like to have a link to this particular presentation, you can see this QR code. If you scan it, you will have this presentation on your mobile phones. Please feel free just to scan that. Can you see it?
Juliana's going to move your picture is covering it and Juliana is moving it. So now we can.
Perfect. Sorry for that. Yeah, I have just put it on the right corner. So if you just scan that, you know, you should get this presentation here. Okay, let's have an example of that. We will have a backgrounds observation, so we will just look at the zoom 0.0. So let's look from far away, and time -1, which means we are looking at the start of the interaction. Okay, first we need to know what the heck interaction is all about. Which interaction are we observing? And we will try to examine the project of designing an information portal for sharing local news on social and natural responsibility from the local environment. And this was actually the project which we did this year with a group of students. The name of the portal, information portal, is odgovorenpika.si, which basically, if you translate that to English, it's responsible.r, or responsible at UR. Okay?
You don't have it yet.
So this is the interaction we would like to see, to observe, and we are only looking at the backgrounds, and we're specifying that. Here you can see background observation, and we just define the zoom level and the time level. Okay, and then now let's look at the environment, the management part of system 1. and the management part of system 2 and the relations between 1 and 2. Let's see what is actually needed to start a project like that. First of all, we need to have the concept of social responsibility defined. They need to exist and they need to be accepted by the public. It took us 30 years to change the environment so that this is being developed in the environment. Okay? And then we need to have the formal framework, which means regulations, which are currently being put out. This is, for instance, the sustainability reporting in EU and the support. So basically, we need to have some support from the system for these interactions actually to occur. And this needs to be developed. I mean, with a thought. And for this particular one, we actually got the support. Financial support enabled us to invoke a group of students to actually work on that. Okay? Now let's see what needs to be present, which structures needs to be present in system 1. So the first system is IRDO. IRDO is Institute for the Research of Social Responsibility. Okay? And they had to develop the capacity to drive social responsibility. It took them 20 years to do that. They are on the ball with the topics of social responsibility, which they basically put in because they work with companies all the time. Okay? They needed to have the idea, the concept of odgovoren.si, that is the portal name. They need to provide some kind of conceptual design of that one. And they're the one to have links with stakeholders. So these are the structural things which are being there by the IRDO company, okay, the IRDO Institute. So this is the managerial part of the IRDO Institute. Now, in order for this to happen on the other system, some structures needs to be developed as well. And as you can see, we are looking at very far away. Okay, so on the other side is the Faculty of Economics and Business, my faculty, which need to be somehow related to social responsibility as well. Otherwise, it would make no sense. And when researching the backgrounds, I basically established that the faculty has a 40 years tradition in social economics. So basically, it is something which is related to social responsibility and sustainability, with 3 founding members of the faculty. The last one, I might think you know, it's Matthias Molle. And we have developed a vision of social responsibility and sustainability and mechanisms how to put it in our work with students and also how to put it in our work with the environment. So we are on the same page here. We are actually developing engaged students, because if you want to put a socially responsible platform, design a social responsibility platform with students who do not know the concept of sustainability and social responsibility, it will not work. Okay, so we have developed and we are developing engaged students which have insights in business and IT. We need somehow business, social responsibility, IT students who can do that. We're holding conceptual knowledge on system thinking, social responsibility, and sustainability. So we are doing that. Okay. Now, what's the relation? Are the relations actually necessary to conduct a project like that? I think they are. Okay. And when we examined, is there a relation between IRDO and Faculty of Economics and Business? Well, the head of IRDO is a former student of ours. Matthias Schmule was her mentor. So she started to develop that 20 years ago under the guidance of one of our professors. So it's not something which is unrelated. Several professors are members and hold certificates of social responsibility issued by IRDO. I work with IRDO for the last few years because I was the mentor at the faculty, and for instance, participate in the IRDO conference, which happens every year. And at that conference, we put in students for free, of course, as participants, active participants at the conference. So we did that, and this is basically, these are past interactions who have basically developed the relationships between IRDO and EPF. Okay, so this is the structural part. This is the part which is the structural backgrounds who allow us to go and conduct the interaction, which is development of the project. Okay, now let's have a look at the interaction part. Okay, so we could see the environment interactions is very important. There was a call from the regulator, supportive one. We will finance a project which deals with sustainability, which deals with social responsibility, which develops the capacity of students and work with organizations. So somebody from the environment decided that they would like to support this kind of interaction. Okay, there we had these repetitive interactions, right? Which means that we have done things before. For instance, the IRDO conference. Have we done any projects before? No, we have not. So this is the first project. The interesting part is that after this project has been carried out, we already started to talk about the next project. So we are opening the projects. And sub-interactions, there were several small things that need to be done. For instance, applying for a project, support of the project office, support of the students. So many of the sub-interactions had to be executed. And this is something that needs to be observed. And some of the related interactions, all of these are basically events which are related to social responsibility and have been executed within the month of the application by Faculty of Economics and Business or the IRDO. So, all these have been there. Okay. And this is merely the background. So we have observed a part of an interaction only to explain what it takes for interaction just to emerge. Okay, what is missing? Additional observation points. We could, and I know that my time is over, so I will be brief. We could inspect the project setup perspective, which is a little bit zoomed in. You see zoom 0.8, and it is just before the actual execution of the interaction started. We could decide to see the execution. We could decide to see the projects, and we could decide to examine, to observe the implications and just write them down. And the good part is that this is not an objective observation. It is a subjective observation. How can we get an objective perspective? Well, we need multiple observation by multiple observers. And then we can get an objective observation. Okay. No, I will not go into, maybe I can show you one picture, but then I will go back. Okay, that's the picture of the execution, which is started like that and ended like that. These are the tasks of the students. What I would like to point out, the missing parts. Okay, and the missing parts are, okay, let's go back, the methodology. Sorry for that. You can see this one. We have examined that, we have examined that, and part of system 1 and part of system 2 and part of relation. Only the first one. The second one we did not examine at all. So basically we did not examine how the interaction affects the environment, the system 1, the system 2, and the relationship between them. Okay? Well, what else did we not observe? We did not observe the network of interactions. We have observed some of those interactions, and we did not observe how an interaction will affect future interactions which may occur. Okay? So, for this time, this observation is incomplete. Is this a problem? Not really, because it is defined. We have defined which parts we observe, leave it there, and if somebody would like to observe other parts, they can do that. And this is how we can create a more holistic perspective of an interaction, of several interactions, of similar interactions, of a network of interactions. And yes, I would like to conclude here. And yes, thank you for listening and looking forward to questions which I can maybe hopefully answer, elaborate a little bit.
Can I come back with some questions?
Yep.
Shall I go and stand in the front if I can ask some questions so you can see me?
Yeah, the camera's here.
The cameras are pointing at the front,
Yeah.
isn't it? So I'll just ask. Igor, thank you. That was really interesting. Can you hear me?
Sorry for just brushing through that.
I'll come and stand here. I have a question. Can you hear me?
Yes, I can hear you.
Could you put up the slide with the two systems for me?
Oh yeah, let me do that.
Wait.
Here?
No.
No, I'm going there. It takes a while. To the structures, right?
The two structures. It's called structures.
That one?
Okay. Can I make some statements? You come back to me if you want. But just looking at that system you put up.
Am I still sharing?
The two, system 1 and system 2, where you've drawn them as separate systems. Can I suggest that the problem lies?
I'm afraid that I cannot hear you.
Okay. Can you hear me now? Can you hear me? Where's the microphone?
I
don't know what happened. I've heard you before, but right now it's
okay. So maybe
quite silent.
Can you hear me now? No. Hello.
No, I can still not hear you. I don't know.
Are we muted?
Ah, now it's better.
Okay. So the first question I have references the boundary that you are choosing and the levels of recursion that you're choosing, because I think you're looking at the same system. You're looking at you're looking at two system ones. So firstly, let me just give you an example. If you have a car and you look at the car as the wheels and the engine and the body as system ones, okay, the road is in the environment. Yeah. But if you now go up a level of recursion and you look at the transport system, the road becomes a system 1. It comes into the system. So where you're choosing your boundary, now the boundary goes out from the system in layers until it gets to the place where there's no effect on the
Okay.
system.
Yeah, I think I can understand the question.
So
Now,
sorry, I just want a little bit more because you
important
need to go
part
up the
is that
level
we are
of
not
recursion.
observing the systems per se.
But
The
you
important
can't.
part is that we are observing the interaction.
Yeah.
So basically, if we are relating to the car, we can have the relation between the car and the driver, or we can have the relation between the car and the road. Okay? But it is always about it is an interaction observation, and in each interaction, there are usually two systems. It could be more, but if you define them, you will see that usually there are two systems. And of course, the recursion is there because, if you look at the internal interactions within a system which need to occur, there is actually even, always more interaction within the system than between the system and the other system. You just zoom in and say, okay, this subsystem is system 1 and this other subsystem is system 2, and they're interacting.
But yes,
you have this recursion level built in the concept.
Yes, but if you don't take into account, so you are basically using the process of a system in focus. Okay, but the reason Stafford used the word system in focus is to not ignore the rest of the system. He didn't say, let's take the system. He said, let's just focus on this system. But you cannot ignore the other levels of recursion. But
yeah, absolutely.
Okay, but
and this is the same. Basically, I'm using the concept of Stafford, but I'm just focusing somewhere else.
Okay, so if we take a different perspective and use Majoran and Varela, then you are taking a structural coupling between these two systems. Okay, so if we take a different perspective, you're using a structural coupling. But one of the main things you don't mention is that if that coupling is asymmetric, then one of them is an agent. So you don't talk about agency and the agency between the two systems. No? Okay. Secondly, Heisenberg, Stafford talks a lot about the Heisenberg principle. Your two formulas should have a feedback loop, I think, because as soon as you talk about observe one system, the act of observing will change the system that you are looking at. So, and second order cybernetics, if we take a third lens of second order cybernetics, then the values of the observer, now you said you could become an objective observer by taking more observations. I would argue this is where you need that higher level of recursion, because if you have a group of people who have the same shared values and beliefs, they're going to make the same observation. Going to Spencer Brown.
I've lost you again.
Okay, so going to Spencer Brown, and that no observer, so the observer is part of the system, and you haven't put your observer into the system. That's my 3 points. Sorry.
Thank you for the comment, and it is a valid one, and we were struggling with that a lot, especially about the part of the observer, because each observation is basically subjective, right? So, and having an objective observation is an oxymoron. You cannot have that because obviously the observer is part of the system, and not only is part of the system, but it is placed somewhere where he or she is biased. Okay? Now, to get an objective observation, not an objective observer, is only if we can put multiple perspectives on the same interaction, then we can get a little bit closer to an objective observation. And yet still we're not doing that. So I would put in this requisite part where we have the requisite holism of the observation and requisite objectivity of the observation. So we should not state an absolute, being an observation objective, because that's not true. We need to acknowledge that first, observers are subjectives because they are part of the system, but this is only an observation. The real question is how to deal with that, how to address that so that the observation is basically usable for reasoning. And I think that's the question. Not just stating the role of the observer, but how to deal with the fact that the observation is subjective. Yes.
Do you want me to ask the question? Sorry, tell me what it is.
Yeah.
So we have one more question, Igor, or some more questions, but the lady can't come across easily. So can you hear me? I'll ask you for that.
Yeah.
Surely what you're discussing is not actually an observer, but an observer's perspective.
So she says, surely what you're discussing is not an observer, but an observer's perspective.
Well, it's an observation, but it is now what we were doing.
Did I ask that right? No.
It's an observation.
It's an observation
From one perspective.
from one
of an
perspective
observer.
of an observer.
Yeah. And if somebody else would have observed the same interaction, their observation would be different. Now,
Sorry.
She
what
says
we try to do here is to have some kind of ontological frame. So we said, okay, let's try to define the zoom level and the time, which point what are we observing and which structures are we observing, so that we have some kind of possibility of comparison of different observations. And that is the main concept. So if we can define, okay, now we are observing which structures in M1 are there and basically should be there, and then we can say, okay, now let's observe the M2 and see which structures are being there and which are being required. That might be very helpful, especially if we can observe and compare different interactions. So if we can put.
You've gone, Igor.
Yeah, that's the idea.
Okay. Does he?
As an observer, I am capable of multiple perspectives.
Yes, so the lady says, Heather says, as an observer, she's capable of multiple perspectives
Multiple observation.
and multiple observation
different
points
positions.
from
That's
different
one
positions. So it's not just one observer with one viewpoint, it's one observer with multiple viewpoints from different positions.
Yeah, yeah.
So
Yeah.
you have a system of observations, is what you're saying?
Variety explosion.
Yes.
What we were trying to solve here is the horribly low quality of data out there explaining, elaborating on things. And this is why AI is basically producing these results which are very suboptimal. Now, if we try to do some kind of structuring, but as little as possible, allowing people to put in, or observers to put in their observations, sorry, then we can basically fill the gap between the real world and what is being explained in the digital world about this one. So basically just slowly raising the quality of the models which are being developed. And that's the task. So we are not talking about, okay, let's try to elaborate everything, but we get an observation. Frankly, I can absolutely agree with the comment, because observations which I made at the point in time about this particular project, yeah, and when I re-inspected them yesterday, I actually disagreed with myself. I said, no, this was not correct. I would like to have it different. So yeah, I agree. There are multiple observations by the same observer. Yeah, there can be. And frankly, I can actually change my mind as well.
Heather has another question. Hang on.
Please.
So I have a problem with this general idea of environment, because you've got natures which exist within an environment.
That's the same point I made, I think, isn't it?
Something
So,
like that.
so it's where you put the boundary to say the
Yeah,
environment,
exactly.
and actually,
And it's the structural coupling of that relation.
so the trouble is that everything is part of the system if it's in the boundary and affects the system.
Correct.
And it's just that Stafford tried to tell us, and in fact, part of the problem is he originally drew the system of the system in the environment, and then he takes it out to show it to you, and everyone then thinks it's separate.
That's right. Yeah.
So it's part of the system, it's part of the environment, and it goes in layers out.
Correct. Necessary.
Yeah. Sorry.
Yeah.
Thank you.
Basically, I had the same issue with the original Beer's diagram, which separated the system from the environment. I did not understand that. And frankly, I still have problems coping with that. This is why the environment is being drawn around the systems, the two systems in interaction. And interestingly, when after drawing that and trying to comment on the observation, you could clearly see that the structures which are required to create an interaction can reside either in the environment or either in system 1 or system 2. That's the interesting part. And, you know, for instance.
Wait, one more. We have one more quick question. Do we have time?
Yeah.
Very quickly, yeah. You want to? Yeah.
Thank you.
Because I don't have the question already. Hello, can you hear me?
You have to shout.
I'm sorry for that. I would prefer being with you in the room. That would be much better. But
You have to shout.
Can you hear me now?
I can hear you, yes.
Okay. So my question goes in this sense. You have to model time at some point, and you decided to do it in like 3 stages: t-1, t0, and t+1. You want to comment before my question? Okay. There is a question.
Yes, can you hear?
Okay, so this is the deal. Wiener said, contemplate the idea of feedback within time, and contemplate the idea that time is not Newtonian, but Bergsonian, which means experiential. And Beer also thought about an experiential time. But every time all of us face the problem of time, fall into that 3 categories that you already did. So if you want to comment on that, I will be more than grateful.
Oh, yes. A very good question. Thank you for giving me the chance to elaborate on that. Let me go multiple observation points, because that was something which was very troublesome for us as well. How to define the observation points in I will call it time and space, right? Because it should be universal. It should go from, time in our present, so the events which happen on our time, to the micro level or to the meso level, for instance, time from the perspective of a life period of a star. And it should work for each of them. So what we said, let's normalize time based on the interaction. And time should start at the beginning of the interaction, beginning of thinking about the interaction, yeah, and it should end when the effects of the interaction on the environment end. So that's the time normalization, okay? And then in the definition phase of your observation, you can decide, okay, now this particular point in time is very important for me. And you just say, okay, I will put in the pin of my observation in that plane and just define it. Because I think that's important for each observation, just to define at which point in time your observation is put in. Okay, so this is not predefined. This is predefined only for this particular interaction, which I posted observation on. If I decide that I would like, that I think that the most important observation point is somewhere else, I just need to define it so that somebody who reads my observation understands what I'm talking about. So it should not be predefined, but I think it should be normalized, because if it is normalized, then multiple observers can agree on where their observation is in. Okay? And so basically, this is why I put in this kind of bullseye and say, okay, this observation here, here, here for this particular observation. Did I answer your question?
Yeah, thank you.
Thank you for now. And I hate to have the black hat on, but time is up. And thank you. And you can continue the topic.
Thank you so much for the comments. And thank you for listening, actually. When you start to explain these things to somebody, he'll say, what is he talking about? And you have produced very, very good feedback. So thank you for that.